This 5-mark question appeared in 2019 May question paper of Mechanics of Solid KTUs. It has 3 subdivisions. Explain the following. 1. Shear force and bending moment in a beam. 2. Hogging and sagging moments. 3. Point of contraflexure. So let us see it one by one. So the first one is about shear force. So first we need to define the shear force. Shear force is the algebraic sum of vertical forces acting to the left or right of any section. Let us take an example of a cantilever beam. And so I'm drawing it. It is loaded at the free end with a vertical load of 10 newtons. Now to find the shear force at a section XX, the shear force at section X will be equal to the sum of forces acting towards the right of this section. So here it is 10 Newton. Let us also take an example of a simply supported beam with a loading at midspan. So the beam is AB, 2 supports I'm drawing now, and it is loaded at the midspan with a load of 10 newtons. So the reaction at support A and B will be equal, and that will be equal to 5 newtons. In order to find the shear force at any section, let us say this section XX, the algebraic sum of all the forces towards the right of the section, that is SFX, will be equal to, as per the sign convention, downward force is positive, so 10 Newton is taken as positive, and the upward shear force will be negative, so minus 5 Newton. So the shear force at that particular section is 5 Newton. If you take towards the left also, that will be the same. Next is to explain the bending moment. Bending moment is the algebraic sum of moments of all forces acting to the left or right of the section. Here also I am taking the example of a cantilever. So this is the fixed end and the other one is a free end. Let us say the beam is of span 5 meters and it is loaded with a 5 Newton load at the free end. Now consider a section XX at a distance 2 meter from the free end. The bending moment at this section, that is bending moment at section X, will be equal to sum of moments of the forces right to the section. Here we have only one force, that is 5 Newton, and multiply it with the perpendicular distance. Here the perpendicular distance is 2 meters, so 5 into 2, 10 Newton meter will be the bending moment at section X. The second part of the question is to explain hogging and sagging moments. So first let's see what is hogging moment. Here is the definition. The bending moment which causes a beam to bend with convex side upwards is called hogging moment. And this kind of bending moment is treated as a negative bending moment. The conventional representation of hogging moment is shown in the figure here. Now let me show an example of hogging moment. Here a cantilever beam with a load at free end is considered. Now when a load like this is acting, the beam will tend to bend like this, that is with the convex side upwards. So this is a very simple example of hogging moment. So now we saw what is a hogging moment. Next let us see what is a sagging moment. So let's see the definition. The bending moment which causes a beam to bend with concave side upwards is called sagging moment. This kind of a bending moment is treated as a positive bending moment. This figure shows the conventional representation of sagging moment. Let us now see an example of a sagging moment case. So this is a simply supported beam, let's say with a point load at the middle. When the load acts at the midpoint, there will be reaction set up at the supports. They are RA and RB. Due to this load F, the beam tends to bend in a shape like this, a concave shape upwards. So this is an example of sagging moment. Next question, explain what is point of contraflexure. It is a point in bending moment diagram where the bending moment is 0. That is, a point where the sign of bending moment changes from positive to negative or vice versa. It is also known as the point of inflection. Let's see an example of this. So here, this beam is an overhanging beam, AB, and the overall span is CD. It is subjected to a UDL of small w Newton per meter. Let's draw the bending moment diagram of this beam. It will be like this. So here I am not showing the calculation or anything. I am just drawing the bending moment diagram based on the types of load and the other conditions. So you can see here there are 2 points where bending moment is 0. This is the first point. This point is called the point of contraflexure. There is one more point where bending moment is 0. That is also a point of contraflexure. If you notice at these 2 points, the bending moment changes its sign. That is, at the left point of contraflexure, the bending moment changes from negative to positive, and at the point of contraflexure at the right side, the bending moment changes from positive to negative.